All right, 10.2 guys, let's go ahead and learn how to rationalize the denominator. Rationalizing means that you're going to turn the denominator into a rational number. If the denominator has a radical in it, you have to rationalize it because it's not considered to be in simplest form. What you'll do is you'll multiply both the numerator and the denominator by the radical from the denominator. So for example, let's start with a really easy one. Say it was 2 over the square root of 3. 3 is not a perfect square, and because there's a radical in the denominator, you can't leave it like this. You have to get the denominator to be rational, and right now a non-perfect square is irrational. So you want to multiply this number by another radicand that will turn 3 into a perfect square, which would be itself. So if you multiply by the square root of 3, 3 times 3 would make that a square root of 9, which would be a perfect square. But remember, whatever you do to the denominator, you have to do to the numerator. Because really, this right here, the fraction we're multiplying it by, really equals 1. And when you multiply anything by 1, it doesn't change the actual problem. So now we end up with 2 times root 3. This is a coefficient, this is a radical, so we end up with 2 root 3. And then root 3 times root 3 is root 9. Square root of 9 now comes out as a 3. So 2 root 3, and the square root of 9 is 3. These two coefficients, if they were divisible by each other, you could simplify it. You cannot simplify these two because this is a radicand and this is a coefficient. So that's your final answer. Division with radicals. If you have a big radical sign over a fraction, just remember it means that it's the radical sign over each the numerator and the denominator. You can break that apart. For example, the square root of 36 over 49 is the same thing as the square root of 36 divided by the square root of 49, which is 6/7. Remember, never leave a radical in the denominator of a fraction. Always rationalize the denominator. Let's look at some of these examples. I think we have, so one screen of this. Hopefully this won't get cut off. It didn't. Okay, what is the simplified form of each radical expression? This really means the square root of 144 divided by the square root of 9 if I broke it apart. Both of those numbers, radicands, are perfect squares. The square root of 144 is 12, and the square root of 9 is 3, and then 12 divided by 3 is 4. So because they were both perfect squares, your final answer will not have a radical in it. Unlike this guy over here, the square root of 36a divided by the square root of 4a to the third. Now, because this is a radicand and this is a radicand, I can actually divide these if they're divisible by each other. So I'm going to go ahead and do that. I have the square root of 36 divided by the square root of 4. Actually, you know what? What's easier, to divide these out and then take square root? Or maybe we should just take the square root of 36 as 6 and the square root of 4 is 2. So let's do that. We could do it either way. We end up with 6 square root of a and 2 square root of a to the third. This is an a to the first, so I can actually cancel these. I could say take 1 from here and take 1 from here. So that's going to give me 6. Square root of a is gone, divided by 2. Square root of a squared is in here. Now that's nice because the square root of a squared comes out, comes out as a perfect square, so it's an a. Final answer comes out as 6. Nope, not a final answer. 2a, and 6 divided by 2a is 3 over a. Because 6 divided by 2 is 3, and a is still in my denominator. There's no radical in denominator, so I'm good. All right, there is nothing that are divisible by here because we have 25, y, and z, so none of the bases are the same. So let's go ahead and separate it. 25y, 25 is a perfect square. Y to the third can be broken down as y squared times y. all over square root of z squared is a perfect square, so we don't need to break it down. Let's take out our perfect squares. Square root of 25 is 5. Square root of y squared is y. This y stuck. Square root of z squared is z. So that guy came out. And now we're left with 5y 5y square root of y, hopefully you can see that, I don't know if it's getting cut off, all over z. So there are no radicals in the denominator. Your square root of y is fully simplified, and your fractional coefficients cannot be simplified. So that's my final answer, which is 5y square root of y, all divided by z. All right, let's look at these. I can't simplify these, they're not divisible by each other. So the only way I can get rid of the radical in the denominator is to turn the square root of 3 into a perfect square, which means multiply it by the square root of 3, but you have to do it to the numerator too. So root 2 times root 3 is root 6. Root 3 times root 3 is root 9. Square root of 6 cannot be broken down, only to 2 times 3, and it's not a perfect square, so we're stuck with that one. And the square root of 9 comes out as a 3. I cannot divide these because this is a radicand and this is a coefficient. So I'm done. All right, the next one, I can't simplify these because 18 and 5 are not divisible by the same number. So let's go ahead. I need to multiply square root of 18. If I multiply that by what? What can I multiply 18 by to make it a perfect square? What about 2? Isn't 2 times 18 36? And m to the first, if I multiply it by another m, that would give me m times m, which would be m squared. That would make it a perfect square. But you got to do it to the numerator as well. So we have root 5 times root 2m would be root 10m divided by square root of root 18m times root 2m would be root 36m squared. So by multiplying by root 2m over 2m, that turned these guys into perfect squares. Square root of 36 comes out as a 6. Square root of m squared comes out as an m. So I'm left with the square root of 10m in the numerator, which cannot be broken down, and 6m comes out from my perfect squares. I cannot simplify these m's because this is a coefficient, this is a radicand, same with this. Okay, the last one, I'm going to break it apart. I'm going to put my radicand over my numerator and over my denominator. We can't simplify these, so we're going to have to multiply. What can I turn 3 in to make it a perfect square? I could turn it into a 9 by multiplying it by root 3. Do it to both. So that gives me root 21s divided by the square root of 9. 21 can be broken down to 3 times 7. Neither one are helpful because they're not perfect squares. And s cannot be broken down. And the square root of 9 comes out as a 3. I cannot divide the 21 and the 3 because they are, one's a radicand and one's a coefficient. And so that will take care of that.